Welcome to The Machine, a computer science education podcast from the Southeast Technological University. My name is Rob O'Connor. I'm a lecturer in the Department of Computing and Mathematics. Today we're going to talk about additive manufacturing, which is probably more colloquially known as 3D printing. Which has kind of totally changed the way things are made and will change the way things are made into the future. On the podcast with me today, I have David Alacro and Natalia Romanyatova. And I hope I have pronounced your names correctly. David, can you just state what your role is and where you are in the context of this conversation?
Yes, thank you. Thank you, Rob, for having us here today. And it's Alarco.
Alarco.
But you did quite good.
I'm so sorry. I'm so sorry.
So, well, my role in this fantastic project is program manager and project coordinator. So basically, I am in charge of making it happen. So delivering the contents, some of them in particular, the introduction to additive manufacturing, I'll do it myself.
So this is in the context of a course. That's
correct. Yeah. Yes, and it is all involved with how are we going to be delivering the course, hiring the lecturers, and also looking for experts that will support and help us to deliver it at its best. And so that's what I do.
Brilliant. And Natalia, what's your role in this conversation?
Hi, David. Hi, Robert. Nice to meet you all today. Well, my role is quite interesting. So I'm instructional designer, but in practice I do so many things. So it's not only creating, developing, but it's also creating the content. It's probably helping lecturers and SMEs to develop their content the best way they can and help them foresee certain situations in the future and escape them. Then I think my role is also a kind of community manager, at least for now.
Yeah.
This is it, I think.
Brilliant. Okay, great. Okay, so we have a kind of manager and instructional designer, I suppose, to kind of set the scene. Okay, let's assume I know absolutely nothing about additive manufacturing. David, I'll give this to you first. What is additive manufacturing?
Yes, so, well, the name says it all, right? So there has been a transition, and I would like to start by here. Many people know this technology as 3D printing. And again, so what we've been used to see photocopies happening, and that's an X and Y, so it's two axes. It's a flat sheet where a little amount of ink is deposited. What we do in 3D printing is that we continue that process. So it is not only one layer, but it's a second layer and a third one that at the end of the day builds up an object. So 3D printing started around 35 or even 40 years ago as an idea, and the technology has evolved very rapidly. Once some of the patents expired in the last 10, 15 years, has been a boom of technology and so many different platforms, so many different solutions. But at the end of the day, all of them build objects in 3 dimensions. The change into additive manufacturing is because it's not anymore a prototype solution, as it was initially. It is now being implemented into manufacturing scenarios, and that is where we are today. And additive it is because compared to any other traditional methodology that subtracts from an existing block of material, and you can imagine a handcrafting of a wood, that you start from a block of wood, and you, with different tools and different expertise, starts carving and removing material. So you're subtracting material to end finding the piece within that block. Could be wood, could be metal, could be different materials, but at the end you are taking away to find. What we are doing is basically the opposite. We're adding up. So it's a much more efficient way of doing things. We're adding material layer by layer with different techniques. We add and fuse those layers together to make a solid and a part that is not for just geometrically representing the object, but actually it can be used as a final part. So the mechanical characteristics are there, and that's part of the evolution that we are about to teach. But certainly this is the basic difference. So additive adds up material and you find your part. And subtractive, which is most of the traditional methodologies, will remove material. So it's a much more efficient from a waste and environmental impact side of things.
So I spoke about this with somebody before, and there was a nice analogy that I'm going to reuse again, which was that it's almost kind of like Lego, in that you build it up layer by layer. Obviously not the size of a Lego brick. It's much finer amounts of material that would be placed to build up an object, and it can be using a whole variety of different types of material. It could be plastics, it could be metals, it could be all sorts of stuff.
All sorts of stuff.
And mixtures of things as well.
Yes, and that's very interesting. There is very innovative materials coming up because of the core science of the process allows those alloys to be done differently. And it is a part of the innovation, the new materials that are now available, and how do you handle those? And eventually, you just said you can mix different materials in the process, and you have the characteristics of both materials now combined aside of the design that we'll speak later. But yes, there is a vast variety, and we're not speaking only of metals and polymers. We're speaking of ceramics, concrete, and chocolate, and biomaterials, and food. It is amazing. It's a huge portfolio.
So everything is made of something, and the way that things are made is changing dramatically.
It is, absolutely.
Okay, so that's kind of setting the scene as to where we are and why additive manufacturing is important and people should know about it.
Yeah.
Right. What is the relationship then between additive manufacturing and general kind of computing? Well, and whichever one of you wants to answer that, go first.
Yeah, I will let Natalia.
I'd say David knows better than
I will let Natalia speak about how we're going to be using technology in our computing. And now with COVID, we have a vast experience again on how useful this media can be to convey interest and to keep lectures going on when someone is locked in their houses, right? But she will take care of that in a minute. What I would like to say about computing and how it has been joint evolution with additive manufacturing is precisely that. So, CAD itself means computed it's computing assisted design.
Yeah.
So basically what you do here is very similar. Let's put an analogy together, okay? So imagine that everybody knows what ABS is. So it's assisted brake system, all right? So since this system was introduced in automotion, so you could brake more efficiently, right? So your car was going to stop much faster or efficiently as soon as you were pushing the pedal. But it was you that was braking, right? So basically it was assisting you to drive better, to brake better, and any other assisting driving or whatever it is. It is you who drives, and the systems help you to do it better with less effort, etc. The system, the analogy goes to the computer assisted design. So it was you that were doing the lines, the circles, the tangents, everything, and the computer was taking care that was done fast, accurately, etc. So it was the digital transformation. But in the last years, this has moved to what we could, continuing with the analogy, compare with autonomous driving. So it is now with Google Maps and all this, is going to suggest what is the best route, is going to drive you there. So at the end, you're going to be sitting and the computer is going to take care of bringing you there safely and in the most efficient way. And the design is evolving in the same direction. So now we have algorithms and artificial intelligence, and we have deep learning. And these systems are not only assisting you from a driving position, but you are letting the computer to propose the most efficient way of resolving a number of mechanical constrictions, a number of space constrictions, and the designs are tremendously creative. And the surprises we have biomimicking, we have generative design, lattices. And the problem is that those designs were simply not feasible. So nobody could manufacture those with traditional manufacturing, right? With injection molding, with casting. The geometries were so complex, the angles were so intricate. Now, additive manufacturing allows those designs to be feasible. And that's what's the beauty. It comes together. So it is a tremendous evolution on the design and computer-assisted 3D modeling, as we call it. And now we have a technology that is not only able to see it on a screen, on a 3D representation in space, but actually manufacture it, and manufacture it proficiently to the point that that is not only visible, but it is even better. Now we're saving material, we're saving, we're making parts that were before required to be injected or fabricated separately and then assembled. Now we can make them as one single unity, right? So it is part of the beauty. So the evolution of the computer-assisted design has now leveraged the capabilities of a new technology for manufacturing, which is additive manufacturing.
Okay, so but it's all run from a computer, as in all the designs are using modeling tools, as you've mentioned, modeling tools that are very precise and very quite complex, and then those are rendered in the physical world by these I see 3D printers, but that's just the term.
That's correct, and this is a concept that we will disclose in our course, which is called the digital thread. And this is very important because that's the actual transformation of the industry. Digital thread means that we are used to design a part, a final part. Then we need to design the tools to make that part. And that could be, again, let's use one of the traditional methodologies, which is injection molding. So we need a tool that actually injects that part, and it does it repeatedly and consistently and robustly for the life of the project, the life of the part. And now that doesn't exist anymore. So we have a design, a 3D modeling part, and then we are able to manufacture that part directly without tools. So the responsibility, and that impacts when we're talking of regulated industry in healthcare and automotive and aerospace, the responsibility, the liability of the consistency of that process now is in a digital space. So that digital thread is going to be the responsible of guaranteeing the robustness of that process. Imagine that you are now printing a hip for someone's that is going to replace a part of his leg or a backbone or something like that. Imagine how important it is that that is done proficiently and robustly and reliably. And regulated industries have been evolving towards this digital concept as well, right? And now there is new trends that are helping those industries to rely that the materials are to the specs that are required, and the processes are also. It's not just about the printer, and we will speak about this on the course. Everybody refers to 3D printing as one single machine, but that machine is part of a supply chain which has been greatly impacted by the revolution that this new technology brings. So the investment that was required to generate these tools was massive, and that had a tremendous repercussion because that investment can only be done in one place, one location. So you had to manufacture all the parts for the world consumption in one location and distribute them globally. Now all that is changing. So we have local demand, local for local. We can really replicate small printing work cells in different locations. And in a situation like the one I mentioned with a pandemic or for whatever reason, natural disaster, a supply chain disruption, this technology brings, aside of the design capabilities that I just mentioned, a number of advantages that the industry is recognizing.
Excellent. So, Natalia, in the context of this conversation then, what is AMASE, A-M-A-S-E?
So AMASE is it's additive manufacturing advancing the Southeast. That's what it stands for. But in practice, that's a unique opportunity for students, not just to learn something theoretical, but also try it in practice. Because we will be using a good amount of labs, and not only in Waterford, but also in Carlo, because this is also a unique feature of this course, that this is a mutual project between Carlo and Waterford, and students will be doing some workshops in both places during the course, and the equipment that we're using on this course some of it, I don't know, David can correct me if it's not, it's really expensive and unique, and not always such opportunities are available on courses like that. So that's a really good side of this course.
Yeah, excellent. So, well, let me back you up there for a moment, because you've mentioned this course. So what is this? So either of you want, like, you're talking about a course. What is the course?
Yeah.
Where does it fit into the mix?
All right. So this is a level 7. It's a level 7 course, and I think it's important to say that it's a funded project, and there's a human capital investment that has funded, and there was 2.2 million. And as Natalia was saying, and this is part of the beauty and the strength of what we are proposing, many of these courses are specific to a single platform, and 3D printing has evolved in many different directions. You mentioned metal, polymers, but even within those, there are many different platforms, and each one of them is very specific from a core science point of view, and there's a lot of expertise required to master any of these production solutions. So we will want to have a first step introducing these technologies. That's why we call one of the modules Introduction to Additive Manufacturing. So it's a whole ecosystem. This is a level 7, and we are conscious of this, is the first step, bringing additive manufacturing to the regulated education spectrum, right? And to do this, as Natalia was saying, we count with the support of very well-known institutions like SEAM, 3D Weed, Design Plus, these technology gateways where this equipment is available. This is not a theoretical teaching. We have this equipment, and thanks to these institutions that have been invested and supported by Enterprise Ireland, and there is a lot of money put in having this equipment, and that's part of the strength, because the students will not just come and learn theoretically, they will be able to put hands-on work and use this equipment, which will make a big difference if they ultimately go to an industry that is willing to adopt this technology.
And the course is a BSc in additive manufacturing, is that correct?
That's correct.
Or is it a BEng? No.
It is called Bachelor of Science in Additive Manufacturing. Yes.
Okay.
So we have let's say that will be the offer. So it's a major award level 7, and it's a blended. So we will it's a part-time. We are conscious that some of the students will come from the industry. Some are already engineers that want to upskill themselves, and that's precisely where this project is born. So now industry is adopting additive manufacturing. So now they rely on this technology to be valid for their solutions. They want to put these parts in the hands of their customers, and that's important. So we need an upskill workforce. So who's going to be running these operation lines? Who's going to be managing? Who's going to be supervisor of these lines? So we need an upskill workforce, and that's the demand that the market needs. And we don't want to have a mismatch between what we offer and what the industry needs. We want to make sure that these students come out of our course with exactly the knowledge they need to be that proficient workforce that the industry is demanding.
From the way you're describing it, though, additive manufacturing is I hate to say revolutionary technology, because that's bandied around a lot, but it's a fundamental change in the way that things are made.
Absolutely.
So like, to me, it sounds genuinely revolutionary. And is this something that pretty much everyone should know about, regardless of, well, maybe not every discipline, but for example, so we have computer science courses. Would it be possible to have an additive manufacturing module that might be available to other students, or other students in engineering or science or what have you?
You nailed it there, Rob, and I think that's precisely the long run. So we're going to have this specific technology in a single separate Bachelor of Science, but certainly everyone that is coming out as an engineer, as a material scientist, as a building engineer, knowing nothing about additive manufacturing will make no sense, really. So I really see this being integrated in level 8, level 9, and following within these disciplines. So in computing as well. So how can you be a computing engineer knowing nothing of an application that is vastly implemented in the industry? So I think it's going to be, yes, integration will be the next step. So let's introduce the technology, because as you said, many people just don't know what is additive manufacturing. We say it as normal, but many people simply does not understand. Once they understand, they will be the ones willing to know more and implement it in these different degrees, right?
Yeah, and so the course is going to be. You said it's going to, so BSc in additive manufacturing, and you can look it up on the SETU website. So you just do a search for it, and you'll find all the material there. Yeah. Right, but you said it's going to be available in kind of hybrid mode. Is that correct?
That is correct.
Okay, so Natalia, this is where you come in as an instructional designer. So the first question I'm going to ask you, right, is let's assume I don't know what instructional design is. What is instructional design, and why is it important?
Well, that's important because it helps provide the content the best way you can, plan the course the best way you can. This is our secret logo on this course, to do the best from the best. In my case, it's not only planning; it's also developing, as I mentioned, and even helping lecturers and SMEs to plan an engagement in a professional way, not only during webinars and lectures, but also throughout the course and throughout every module. And we are using so-called flipped classroom approach. This is a difficult terminology, but it will fit this type of content very well. What I mean is that our students will have a chance to get a feeling of the material before coming to our webinars and lectures, dig into the topic, here to some SMEs that are really good experts in the field, and then engage into it during webinars and lecture, and finally explore further on, and maybe do some assignment activities if it's required throughout some weeks. So this is how we see it. The funding that David mentioned is a huge bonus on this course, because it literally allowed us to be flexible, to plan what we really want, and to use the technology that we really think is good for this particular audience. And we know our audience. So that's a huge advantage of this course. It's not only innovative, but it's also, as we hope, it would be to high quality standard. And we have a great team of experts on the course, and our approach while creating this course is also very fantastic, because we literally work as a team. So originally we started as just two people. Well, before me it was just David. And we gradually grew in a bigger team, and everything we do as a team. So from learning outcomes till activities, we design and discuss everything together. And this is a great approach. I really enjoyed.
Yeah, thank you. So I hate to invoke COVID, but it's the elephant in the room when we're referring to online learning, because some people's experience of online learning will have been a PDF thrown up on a website somewhere, and that's online learning. It's not, as far as I'm concerned. But we've all learned that there is a big difference in the online environment as opposed to the physical environment, and you have to pivot in a different way. You talked about the flipped classroom, and I remember one time somebody explaining to me it's the difference between teaching and learning. They're two different things. So the flipped classroom, where a student, there is a bit of an onus put on the student to have read material before class. So instead of coming in and the material being delivered to you, here's some stuff, read that or experience that or watch that or do something with this beforehand, and then we come to the class and we're going to have a deeper discussion about it based on some previous knowledge. So
right.
Is that the way that you're going with this, is it?
Exactly, yes.
Okay.
So we will do our best to deliver it in such a way, because we the audience that we will have are people that are already coming from the industry.
Okay, so your student cohort are not your typical Leaving Cert people, are they? They're people coming from a professional background. Is that correct?
Yeah, that's right. And even we have a particular, I don't know, David, if you can say we have particular companies in mind.
Absolutely, and that's part of, again, the team that conceptualize this project. And there is a number of companies. In Ireland there's a good number of innovation, and the government has attracted these innovative companies, and most of them in the life science space have adopted or are in the journey of adopting additive manufacturing, and precisely those were the ones generating this impulse to upskill a workforce, and what was needed for that was a formation like the one we're taking care of. Natalia is a fundamental piece of the team, and I'm very happy that she is with us, and she envisioned this way of engaging with the students. So there is 3 phases, as we call it. It's a preparation where the students have access to the material, where they are invited to do some activities to prepare them, to warm them up of what is going to happen in the engaging, as we call it, which is the class itself, with a number of activities. And online teaching is a challenge to keep the dynamics of the class, the interest, to keep the people attentive, and making sure with activities during the class that they are building up the knowledge as we go. And then the exploration. So it's a 3rd phase that happens after the class with activities, assessments as well, and case studies where they will be completing that knowledge and preparing for the next class. So it is very important. We are conscious that our professionals that cannot dedicate a whole week. That's why we will be working only on Fridays. It's a full day on Fridays, but a corporation can send them to attend the course either at home or physically at the campuses, both Carlow and Waterford. But it is only going to be Fridays. So it's going to be an intensive day of 8 hours with 2 modules overlapping. And that means that you better have a dynamic way of keeping the attention of an individual during 8 hours of work, because it's the last day of the week. These people has not been sitting in the sofa. He's been working Monday to Thursday. Now on Friday, they have an intense day ahead. So Natalia is helping to make sure that all the knowledge is conveyed to, but also the interest and the dynamics of the class are there to make sure that is possible, right? It's an intense effort, and we are conscious of that. And with her help, we are making sure that happens as it should.
Brilliant. Right, what would you say is, I'll ask each of you this, okay? And what's the most important lesson anyone should learn about additive manufacturing?
Well, I will take that one, and it is the understanding that it is an ecosystem. I think that is a big difference of what we are going to be doing and what other people is doing. Not worse, no better, simply because we want the students to have a complete understanding of how much of an impact this technology is making in society. That means cost modeling, business opportunities, environmental impact, supply chain disruption, design iteration processes, development phases, how are all of them changing? So it's not just a cool design that now is possible, and we see all this topology, beautiful structures that now are possible to be made, which is on its own brilliant enough. But it is just a part of it. It's a partial approach. What we really want is that they have a complete vision. And yes, there is a balance between breadth and depth, and that means that we will not be able to go eventually so deep in a particular solution. And we are conscious as well that there is a level 7. Mm-hmm. So the entry level is level 6. We can have professionals and we can have students that coming from level 6. And we are conscious of that as well. But the challenge and the beauty and the proposition that we are bringing to the academic person or individual, this innovative individual that wants to know what additive is, that he comes out understanding the end-to-end and all the impact that it means for society, for the world, right?
Mm. Okay, well, Natalia, I'm going to feed you a slightly different question then. What would you say everyone should know about instructional design? Or even what should everyone know, take as a lesson about online delivery or online learning? What would you say is the most important thing?
Well, the most important thing is I think, that the learner is the center of everything. Whatever you design, whatever you do, you are focused not just, say, learner, but at a particular audience in mind. That's exactly what we did. We created learner personas, and we will develop them throughout the course. So you're having your audience, whatever you're doing, creating activities, designing learning outcomes, thinking about interactivity, assessment. You think, does this audience really need it? How will they benefit? Not on the course, but in their life. That's their final aim, to come back to their companies and get better job or get inspiration in what they do. So that's our final aim.
Excellent. If somebody wanted to find out more about AMASE and the work that you're doing, what's the best place to go?
Well, we have a website. It's amase.ie, and they will find information about the course, and there will be a link to the SCTU where they will find more details about how to apply a calendar and the credits that they will be getting, the entry levels, whatever question they have. There is my name there, my phone number and my email. I'll be happy to answer any question.
Brilliant. And that's AMASE, spelled AMASE. It's Additive Manufacturing Advancing the Southeast. David and Natalia, thank you very much for speaking with me today. I wish you all the best with AMASE, with the BSc in Additive Manufacturing, and I might come back and pick your brain about maybe this could be something that could be offered as elective modules or modules in other undergraduate programs across SETU. I think it would be certainly interesting. If you want to learn more about the machine, check us out online, podcast at machine_podcast on Twitter. There's a Facebook page. I don't update it very often because I'm not really into social media, and I believe on the new SETU website we're going to have a dedicated podcast section. I don't think it's there yet, but it will be at some stage in the not too distant future. Okay, folks, thank you very, very much.
Thank you very much for having us here today.
Thanks, Deborah.